Rahim. Assalamu alaikum. Welcome to another video of chem-solve. Today we are going to do the third lecture of our Introduction to Organic Chemistry playlist, and the today's topic is alkane. So let's move towards it. The name of today's topic is alkanes. You must remember that we discussed in, I think, the first lecture of organic chemistry that there are different homologous series in organic compounds, and alkanes is the one of them. So basically in O-level syllabus we have to study about 4 homologous series in organic chemistry, and the first series that we are going to do is alkanes. So look at the definition of the alkanes first, how we can define them. Alkanes are homologous series of hydrocarbons. We have already discussed what are hydrocarbon in our introductory video of organic chemistry, that contain only carbon-carbon single covalent bond. So in alkanes there is a carbon-carbon single bond between two carbon atoms. Let's see how does it happen. For example, there are two carbon and there is a single bond in between them, that is a single bond. You know, carbon has 4 valence electron, so it needs to make 4 covalent bond. The rest of the 3 covalent bond will be formed with hydrogen. Students feel normally confused that how do we know that how many hydrogen are going to attach. So it's very simple, just draw carbon and there should be a single bond between the carbon. Now look at the first carbon, how many bond it would have? It has only 1 bond, so I need to draw 3 more bonds, and with these 3 bonds I will attach hydrogen. Alright, so resultantly each carbon atom would have 4 covalent bond around it. You can see this carbon has 1, 2, 3, 4, and this carbon also has 1, 2, 3, 4. So we just have to make this numbering 4 around carbon atom. Now coming towards the next thing, that how to make the formulas of the different alkanes. For that we know that alkanes have a specific journal formula. What is the journal formula of the alkanes? The journal formula of the alkane is CnH₂n+₂, where what is N? N is the number of carbon atoms in the alkane molecule. All right, so let's see that how does it work. Let me draw a table for this. Name, number of carbon atom, and molecular formula. Okay, how do we name alkanes? We have already discussed it in our first video of organic chemistry. So today we will focus mainly on how to make their formulas. We should remember that the general formula is CnH₂n+₂. This is a general formula. Now I will fit the carbon number here, and I will find out that what is the molecular formula of that specific alkane. For example, if I have to make the carbon number 1, so instead of N I will write here 1 H2 into 1, that would be 2 plus 2, that would be 4. So the molecular formula would be CH4. All right. Now make another one. Okay, if the carbon number is 2, so instead of N I will place 2 over here. 2 N into 2 plus 2, it would be 2 2 are 4, 4 2s are 4 plus 2 is 6. So that would be C2H6. Okay. Now if the carbon number is 3, so instead of N I will write 3 H2 into 3 plus 2, so it would be 6 plus 2, it would be 8. So in this way, third carbon atom, having 3 carbon atom in a molecular formula, alkanes have C3H8. Similarly, if I have carbon number 4, for example, then instead of N I will place 4 over here. H is 2 into 4 plus 2, so that would be 2 4s are 8 plus 2, that will make 10. So the formula would be C4H10. I hope you have understand this. Okay, so now look at the names. How do we name it? I have told you earlier that if carbon number is 1, then it is meth. And for alkane we add ane at the end, plus ane. So it would be methane. Okay. For carbon number 2, we write eth, and at the end we have to add ane, so it is ethane. Carbon number 3, it is prop, and we have to add ane at the end, so that would be propane. Carbon number 4 would be bute, and we add ane at the end, and that would be butane. So that's how we can make the formula of any of the alkane by using its journal formula, that is CnH₂n+₂. Whatever carbon number we are going to use, we will just replace this n with that carbon number, and it will work in to find out the molecular formula of that specific alkane. And similarly, we can name it by using our prefixes, which are meth, eth, prop, bute, and so on. And we will add ane at the end of every name for alkanes. Now, one important thing that you can deduce from this molecular formula list is that give me a second. Each member of alkane differ from the next by CH2 units, that is also called 14 units. How this 14 unit is being obtained? We know that carbon has AR of 12 and hydrogen has 1, so 2 hydrogen are 2, so it would be 14 in total. Understood? 14 units. For example, methane is CH4, and if we add CH2 in it, it would be C2H6, that is the next member. Similarly, C2H6, if we add another CH2, it would be C3H8. Can you see? I'm getting the successive member just adding CH2 in my previous formula. This is an important thing that you must remember. Okay. Normally in question, in your theory exam, normally examiner asks that what is the structural formula of the given molecular formula, or what is the displayed formula for the given molecular formula. So how do we represent them? How do we represent the different molecules in their structure formulas and in their displayed formula? For that, we have to make another table. Hold on. Let's draw the table. Okay. So first of all, name molecular formula, structural formula, displayed formula, and dot and cross formula. I hope from this table you will well understand the differences between all these type of formulas. Sorry. So if I have methane, for example, so we just have discussed that methane has CnH₂n+₂. The molecular formula would be CH4. The structure formula would stay the same, that is CH4. But for displayed formula, we have to show all the bonds. So I will write it like this. And for dot and cross formula, what I have to do, I have to draw a carbon atom, and it has 4 electrons, and these 4 electrons are bonded with 4 hydrogen atoms like this, and each hydrogen atom have its own 1 electron. All right. So now let's move towards the next one. Ethane. Ethane, you know, have 2 carbon atom. So CnH₂n+₂, it makes C2H6. Now I have to draw all these 2 carbons separately like this. This is the structure formula. All right. And for displayed formula, I have to show all the atoms and all the bonds like this. I hope I'm clear. Now for dot and cross formula, I'm gonna make 2 carbon. Each carbon are sharing 1 pair of electron, and they are left with 3 of their electrons like this. So these 3 electrons of each carbon atom will form a covalent bond with 3 hydrogen atom separately like this. All right. Let's make these lines a bit longer. So moving towards the third member of the alkane, that is of course propane. Okay, so now make the molecular formula using general formula CnH₂n+₂. It would be C3 and H8. I have to write all the 3 carbons with their hydrogen separately, and this is called the structure formula. While for displayed formula, I have to draw all 3 carbons with their bonds like this. Can you see, displayed formula is basically showing all the atoms present, and it is also showing all the bonds present. Now I will draw 3 carbon atoms like this. Each carbon atom is sharing one pair of electron. This one would have 3 more electrons. This would also have 3 more electrons, and this one would have 2 more electrons. Now let's draw the hydrogen, which will make covalent bond with these electrons of each carbon atom. Let me draw it. Okay. Now I hope with the help of this table you can well understand the difference between molecular formula, structure formula and displayed formula. Now a very important question that is frequently asked in your theory exam, and this question says, why alkanes are called saturated hydrocarbons? Why alkanes called saturated hydrocarbons? This is a very important question for your theory exam, so let's answer it. There are several points which can make you understand this question. The first is that there is only carbon-carbon single covalent bond. So, as a first point, I can write they contain only carbon-carbon single bonds that we have already discussed in the start of this lecture. So, all the outer electrons of each carbon atoms are used in forming single bonds with 4 different atoms. And the last point is since each carbon atom in alkane can bond to maximum of 4 other atoms, the alkane is said to be saturated. I hope you understand this concept, and if this question comes in your exam, so you can write exact these wording and you will get full marks, inshallah. Now the next topic is the properties of alkane, and more appropriately we will talk about the physical properties of alkane first. So let me give the heading. Physical properties of alkane. Okay. Generally, all alkanes have low melting point and boiling point because they have weaker force of attraction between them. Insoluble in water. Reason: water is an inorganic compound and they are organic, and they are soluble in organic compounds. These are the general physical properties of almost all the alkanes. Now there are certain properties of alkanes which vary when we move down the series. So, next heading is physical properties of alkane that varies on going down the series. What are those properties? Let's discuss. The first property is their melting and boiling points increases. Let me explain how. When we move down the series, for example, we have methane, then we have ethane, then we have propane, then we have butane. So can you see the number of atoms are increasing when we move down the series? So as the molecular size increases, the force of attraction between the molecule also increases. So what could be the shortest and easiest reason for that? Because the size of alkane molecules increases, the force of attraction between the molecules also increases. That's why more energy is required. Okay? The next trend that increases as we move down the group, it is they become more viscous. Okay, so let's understand that how does it happen. Let me write the series again. First is CH4, then C2H6, then C3H8, C4H10, C5H12, and so on. So as the molecular size increases, as you can see, they increase. It is CH4, then C2H6, then C3H8. So more atoms are being involved. That's why the molecular size increases. So as the molecular size increases, there is a stronger attraction between alkane molecules and they become more viscous. Mean they flow less easily. The last one is they become less flammable. In the last lecture, we have discussed that petroleum is a mixture of different hydrocarbons, mainly alkanes, and obviously hydrocarbons or petroleum, they are all flammable. So alkanes are also flammable. alkanes are flammable, meaning they burn easily. In air. Okay, so how this property varies as we move down the series. Again, the reason is molecular size. So, as the molecular size increases, the percentage of carbon in the alkanes molecule also increases, and they become less flammable, and hence produces smokier flame. Okay, these are all the short questions to be asked in the theory exam, and you can just write them the similar way I just wrote over there. Now we are moving towards the next topic, and that is chemical properties of alkane. Okay, before talking about the chemical properties of the alkane, there is another important question that is frequently asked in exam, and that is, why are alkanes generally unreactive? So let's talk about it first. We have already discussed that alkanes have carbon-carbon single bond. So I can write alkanes consist of only carbon-carbon single bond and carbon-hydrogen bonds. They are strong bonds, and obviously due to this they are difficult to break. That makes alkanes generally unreactive. Okay, However, alkanes undergo some of the chemical reaction, and one of them is combustion. Before talking about the combustion of alkanes, let me tell you that combustion is the property of almost all the hydrocarbons, and they combust in a similar way. For example, in the case of alkane, what happens? We take alkane, it burns in the presence of oxygen, and it produces carbon dioxide plus water. This is the general trend. So let's write the equation for any of the alkane. For example, methane, it will burn in the presence of oxygen, and it will produce carbon dioxide and water. In order to balance it, I have to put 2 over here, and in order to balance hydrogen, I have to put 2 over here. Now the whole equation is balanced. Always remember combustion is highly exothermic. Okay, it always produces heat. I want to add one more thing here. Combustion is normally of two types. The one is called complete combustion, and the other one is called incomplete combustion. There are several ways to differentiate them, but here I will just add 2 important points. The first point is incomplete combustion, sufficient oxygen is being provided, and in incomplete combustion, limited supply of oxygen is given. Secondly, the products are always carbon dioxide and water, but here the products are carbon monoxide and water, sometimes carbon as well. So this is the main difference between them. Now move towards our next chemical property, and that is substitution reactions. Substitution reaction is a very important property and you can say it is the characteristics of an alkane. Alkanes always undergo substitution reaction. So you must remember 2-3 things for this. Let me write. Okay, so the first thing is substitution reactions are the characteristics of all alkanes one hydrogen atom of alkane is replaced. Replaced is another word for substitution. Is replaced by one halogen atom usually chlorine. And last important thing is that they take place in the presence of ultraviolet light, the UV light. Okay, so let's see how does it happen. We just take one methane molecule, for example. Let me use some other color for that in order to make it visible. So, for example, methane, we add chlorine in it in the presence of UV light. It will change into chloromethane and hydrogen chloride. Let me write the chemical equation for this. So CH4 into chlorine gas in the presence of UV light, what would happen? Only one hydrogen will be replaced with one chlorine and HCl gas would be produced. So let's understand it in detail. How does it happen? I'm gonna take a simple methane molecule here and let me add one chlorine molecule here. So what would happen? Three hydrogen of this methane will remain at their place, but one of these hydrogen, for example this one in this case, it will be replaced with one chlorine like this. Okay, and similarly if I add one more chlorine in it, 2 hydrogen will remain at their place. One hydrogen was already been replaced, and now the other hydrogen, for example this one, it will be replaced as well with 1 chlorine. Always remember that 1 HCl will also be produced in each step. Let's move further. I'm gonna add 1 more chlorine here. So 1 hydrogen will remain at its place. Already we have attached 2 chlorine with it. Now the third hydrogen, for example this one, it will be replaced as well with 1 chlorine, and similarly 1 molecule of HCl will be formed here. Okay, moving further, if I add 1 more chlorine in it, what will happen? The last hydrogen of this methane group will be replaced as well. So eventually this methane molecule has replaced all of its hydrogen. Initially it has 4 hydrogen, but now it has 4 chlorine here. Let me write their names. This is of course methane. We have added 1 chlorine here, so it can be chloromethane because we just have added 1 chlorine here. Now 2 chlorine has been added here, so the name for this molecule would be dichloromethane. Here we have 3 chlorine atom, so that would be trichloromethane, and the name for the last one would be tetrachloromethane because it has 4 chlorine atoms attached with it. So my dear student, this is called the substitution reaction, in which at every step 1 hydrogen is being replaced with 1 chlorine. As you can say, 1 hydrogen is replaced by 1 chlorine at each step, and eventually we have replaced all the 4 hydrogen of this methane molecule. This is all for today. Thank you so much. Allah Hafiz.